Okay. Let some people join us. Okay, so let's start. So, hi guys, how are you all? I hope all of you are doing good in these tough times of COVID and Omicron viruses that are coming. I hope all of you are staying at your homes, studying and preparing for your JEE and NEET exam really well. So, first of all, I just want to ask you, how is the quality of the broadcast? That is 1 for the worst and 10 for the best. You can just rate it from 1 to 10. If you can see me properly and if you can hear me properly, you can just write down in the chat section, and I'll be able to see that if you are able to hear me properly and see me properly or not, and then we'll move forward, right? So can you please write down in the chat? And okay, okay. So we'll be moving ahead, and I just want to ask you, how is your preparation going on for your JEE, for your NEET, and for your upcoming board exams part 2, right? So many of your exams are going on, and how is your preparation going on? That is, you can rate it from 1, 2, and 3. That is, 1 for a sad face, second for a mild face, and third for a happy face. That is that your preparation is going really well, right? So you can just comment down, right? So I just want to tell you about us. What do we do? What is our name? Our name is, we work at Altedemy. We teachers teach you for JEE. I am your chemistry faculty here. My name is Khushang, and we provide you many free lessons and as well as paid courses for your JEE exam. We have our Telegram channel. You can join our Telegram channel, that is Alt J and Alt Neat also. And if you haven't subscribed to our YouTube channel, that is Altedemy, then you can subscribe to the YouTube channel. You will be getting some free videos like these, and many of the upcoming courses. And we just provide you the lectures, and we have designed the courses in such a way that it will be really easy for you, and you'll not be facing the problems we faced during our when we gave our JEE exam. Actually, most of the faculties here and myself too have given JEE few years back, and we know how much problems and which problems do we face in which chapters. Actually, we have designed the course in such a way, and we teach in such a way that you will not be facing the problems which we faced. And we as a student knew what problems do we face when a teacher who is highly experienced is teaching you, and he is not giving you a proper attention, and which things you lack, actually which particular topic is there. When teacher teaches you, you are not able to understand that, and you go to your friend and just ask him to please explain it to you. So you can consider me your friend, and you'll be when I'll be explaining you the topics, you will be considering me as a friend, and you will be getting the topic with a clear and crystal, you can say, with a clear and crystal concept in your mind, right? So today we'll be going on with the Nernst equation, which is a topic in electrochemistry, which is very important, and we'll be solving some questions on it, right? So first, and moreover, I just want to tell you about our courses, that we use a flipped classroom method, right? What is a flipped classroom method? Actually, this method is used in most of the universities which are outside India, for example Cambridge also. And in this method, with the use of this method, we have seen the students get their marks increased up to 60-70% even, right? So what is the flipped classroom method? Actually, when we are having this lecture, before this lecture, if you are having a paid course, or if you are enrolled in our one of our courses of JEE or NEET, so you will be getting the PDF of this lecture, right? So before this lecture, you'll be getting the PDF, and you'll be reading the PDF that these are the topics. this is a detailed explanation. You are just reading the topic out. Then we'll be having this class where we'll be interacting and we'll be discussing that topic up to 1 to 1.5 hours. And after the class, I'll be giving you, and the faculties will be giving you some questions which you will be solving. And after you solve the questions, you will be getting the homework solution videos to that homework. And we'll be checking your homeworks. That will be a proper test, and we'll be checking your homeworks. You will be getting your marks. You will be getting where which topics you are lacking in, and you are just getting the whole concept crystal clear in your mind that this is the concept. I have read this, then we have a class on it, then I solve the questions on it, then these are my marks. This is the topic which I couldn't have which I couldn't you can say couldn't understand. And you will be added to WhatsApp groups as well, where me and other teachers are there, and you can just ask your doubts directly. Actually, we just focus on one-to-one interactions, and we do not lack, or we do not let any student lag behind, and we just give attention to each and every student so that each and every student can excel, right? So when we were also preparing for JEE, we had also joined some coaching institutes in which teachers just focus on the toppers and just focus on them so that they can bring good ranks in JEE, and their institute's name is highlighted, right? We do not do that here. So I have explained you some of that, and I have told you about our Telegram channel, our YouTube channel, our Instagram. You can follow us on Instagram, that is at the rate Altedemy, and you can just join that and get your preparation boosted. So moving ahead, telling you more about myself. I am an engineer by my choice, and I am an engineer from one of the most prestigious universities of the nation. And I cleared JEE a few years back, and my main interest lies in software development, as it is written, and I enjoy mathematics the most. Chemistry is my forte, and that's it. So my name is Khushang, as I have told you. So we'll be starting with Nernst equation, which is the topic of electrochemistry. So we'll be starting with Nernst equation. Okay, we'll be writing this on the next page. Okay, so we'll be starting with the Nernst equation. What is the Nernst equation, uh, and what is its formula, how it is represented, why is it used, what is the correct use of Nernst equation, why was it necessary to provide such an equation? uh, the answer is, as in electrochemistry you have studied about cells, I am expecting that you have studied about Daniel cell, electrode potential, and cell potentials up to now, and this Nernst equation is the topic after that. If you have studied the basic, now we are moving on to the Nernst equation. So if you haven't solved that, or you haven't revised that electrode potential, cell potential topics, and you haven't studied about the Daniel cell, then I request you to please go back, and you can just study those topics, and then you can watch this video. This will be on the YouTube for free, right? So first we studied about Daniel cell, that is, in this Daniel cell we were having the equation as Zn solid plus Cu2 plus aqueous was going into Zn2 plus aqueous plus Cu solid, right? So I'll be giving you just brief overview of everything. So zinc was a was more reactive than copper, so it will be getting oxidized by giving its 2 electrons, and copper will be getting reduced by taking 2 electrons given out of zinc, right? Why? Because zinc is more reactive than copper. How do we know that? We just checked it from the metal activity series given in your NCRT, right? So we represent this cell we represent this cell. First we write the anode Zn, then we write it like here Zn2 plus, then we have a double bar, then we have Cu2 plus, then we have Cu solid, then here solid, here aqueous, then here aqueous, then here solid, right? So this is the method and this is how we represent the cell. And then we calculated electrode potentials. What was electrode potential? What was electrode? What was the electrode potential? Actually, it was the potential difference between the electrode and the electrolyte. As in Daniel's cell, we had two beakers in which one zinc rod was there, one copper rod was there. Zinc rod was dipped in ZnSO4 solution and copper rod was dipped in CuSO4 solution, and these were connected with a wire. So this ZnSO4 was a electrolyte, right? You remember this? And this CuSO4 was also the electrolyte. So if we divide this cell, this is one half cell and this is another half cell of the reaction. So when this zinc rod zinc metal rod, so what is the electrode potential? Was the potential difference between this zinc rod and this electrolyte, this ZnSO4 solution for the anode, right? And when we calculate the cathode potential, we had the potential difference between this copper rod and the CuSO4 electrolyte, right? So we got to know what was the electrode potential. Then we calculated what was the cell potential. What was the cell potential? E was equal to E cathode minus E anode. That is electrode potential of the cathode minus electrode potential of the anode, which we calculated in the previous thing which I explained you, where we calculated the potential difference between zinc and ZnSO4. It was the potential difference of anode, as zinc side was the anode. Why? Oxidation happens at anode, reduction happens at cathode. I told you there is a shortcut of red cat. What is red cat? You just have to remember red cat, that is reduction will happen at cathode, and obviously vice versa, oxidation will happen at anode, right? So when we calculated this anode and cathode potentials, how? By calculating the electrode potentials of both. Then we have to calculate the potential of the whole cell, which was the whole apparatus. So it will be the electrode potential of cathode minus the electrode potential of anode, right? So and I have told you about the standard electrode potentials also, where all the concentrations are unity and the pressure is 1 bar and every condition is standard. There temperature is 273 Kelvin, right? So now we'll be moving on and coming on to the main topic, that is our Nernst equation. What is the Nernst equation? The formula for Nernst equation is E, that is the potential, cell potential, Mn plus going into M minus is equal to standard electrode potential of Mn plus going into M minus RT by NF Ln. You will be saying, what the hell is this? Such a complex equation. But I'll tell you, it is very very simple, and I'll tell you a shortcut also, where you don't have to write this, and I'll tell you some shortcuts and you don't have to write this RT by NF again and again, right? So first I'll be explaining you what is the actual what actually all this is. So this is the cell potential, this is a standard electrode potential, right? And this R is the gas constant. Every one of you must know that it is a gas constant. T is the temperature. F is the Faraday constant. Faraday constant. It is equal to 96500. Right? So you don't need to just, you can just keep it in mind. You don't need to remember, right? So what is N? Number of electrons involved. When we study a cell, always there is a redox reaction going on, right? So the number of electrons which are used in oxidation and reduction, for example, when we saw the Daniel cell, we had Zn solid plus Cu2 plus going into Zn2 plus Cu solid, right? So 2 electrons were given by zinc to copper. So the number of electrons used were equal to 2. So number of electrons is equal to N. Then there is a concentration of metal and there is a concentration of the ion. This is the Nernst equation. So moving ahead, this M, this M is a solid and the concentration for solid is equal to 1 always. So our new Nernst equation becomes new Nernst equation, E M n plus M will be equal to E naught M n plus going into M minus RT by NF and ln 1 by Mn, right? So when we apply this Nernst equation, let us apply this Nernst equation in Daniel cell. Or should I tell you the definition and you can just write down the definition for this Nernst equation? What is the definition for Nernst equation? The Nernst equation is the relationship between the cell potential to the standard potential and to the activities of the electrically active species. What is the electrically active species? The electrons are exchanged, so they are electrically active, right? And it is the relationship between the cell potential to the standard potential. So we'll be writing this definition of the Nernst equation. The relationship between the cell potential to the standard potential and to the activities of electrically active species, right? So this is the definition of the Nernst equation. It is the relationship between the cell potential, that is E will be equal to E naught plus minus RT whatever, right? So it is the relationship between the cell potential to the standard potential and to the activities of electrically active species, right? So moving on, we'll be applying this Nernst equation to Daniel cell. Apply to Daniel cell, right? So right here. right? So when we apply this Nernst equation to the Daniel cell, what is the cathode in the Nernst equation? What is the cathode? Cathode in the Nernst equation is E Cu2 plus 2 Cu will be equal to E naught Cu2 plus going into Cu minus RT by NF. What is N? It is equal to 2F ln 1 by Cu2 plus, right? And what is the equation for anode? What will be the equation for anode? It will be equal to E Zn2 plus 2Zn. Actually, you are seeing here, when we always use Cu2 plus 2Cu, Zn2 plus 2Zn, we always take the reduction potential. Why? Because it is the convention. There is no reason behind that. It is a convention that we always use the reduction potential or the standard reduction potential and the reduction potentials everywhere. You will not be seeing oxidation potential anywhere, because by convention we use the reduction potentials, right? Will be equal to E naught Zn2 plus going into Zn minus RT by 2F ln 1 by Zn2 positive, right? So when we calculate the E cell for Daniel cell, what will be the E cell? E cell will be equal to E cathode minus E anode will be equal to E naught will be equal to ECU2 plus going into Cu minus this, right? So we'll be subtracting the equation 1 and equation 2. So E naught Cu2 plus 2Cu minus RT by 2F ln 1 by Cu2 positive minus E naught Zn2 plus 2Zn plus RT by 2F ln 1 by Zn2 positive, right? So solving this even more, what we'll be getting is E cell will be equal to E naught Cu2 positive to Cu minus E naught Zn2 positive to Zn minus RT by 2F is taken as common. Then we calculate. Ln 1 by Cu2 positive minus ln 1 by Zn2 positive. And we know the property of log that ln A minus ln B will be equal to ln A by B, right? So let me take a eraser. We'll be erasing this. Okay, so will be equal to E cell will be equal to standard electrode potential of Cu2 plus to Cu minus standard electrode potential of Zn2 plus to Zn minus RT by 2F ln Zn2 positive divided by Cu2 positive. Actually, when we write the equation for the cell, which was equal to Zn solid plus Cu2 positive aqueous going into Zn2 positive aqueous plus Cu solid. So what we will be seeing is that we can generalize this Nernst equation by this. That is, this is the product and this is the reactant. And here the product's concentration, that is product's ions concentration and reactant's ions concentration can be written directly. So we'll be generalizing this equation. So analyzing the Nernst equation, what will be it equal to? It will be equal to E cell, where the difference of cathode minus anode, standard electrode potentials of cathode and anode, where will be given as RT by NF Ln, that is, you can say product divided by reactants ions concentration. It will be the Nernst equation for a complete cell. For a complete cell, right? So we'll just be solving one question based on this. The question is, represent the cell in which the following reaction takes place, and we have to calculate the E cell for this cell also. So the reaction is Mg solid plus 2Ag positive, and its concentration is 0.001 molar, will be going into Mg2 plus, concentration is 0.130 molar plus 2Ag solid. So we have to write the cell equation and we have to calculate the E cell for this reaction as well, right? So, and EV, that is the potential for this cell, is given as 3.17 volt. It is a very simple question. We just have to put the values given in the Nernst equation. What is the Nernst equation? We'll be writing the Nernst equation for this. Nernst equation will be writing at E cell will be equal to E naught cell minus RT by MF Ln Mn plus divided by, so I'll just erase this and we'll be solving the question. Will be E cell will be equal to 3.17. The standard potential of the cell, that is E naught cathode minus E naught anode, is given, minus RT by MF. 2 electrons were there, so we'll be writing 2F will be equal to N Ln Mg2 positive, that is product's concentration, divided by the reactant's concentration, will be equal to Ag2 positive, and there was a stoichiometric coefficient of 2 in front of Ag, so there will be a stoichiometric coefficient of 2 here. So it will be equal to 3.17, and let me tell you a shortcut, that is RT by this is always equal to 0.059 RT by F. So 0.059 by 2 log of, and we have to convert this ln into log. How do we convert ln into log? We just multiply it by 2.303. So it is equal to 0.059 by 2 log of right. So it will be equal to 3.17 minus 0.21, which is equal to 2.96 volt which is our answer to the problem. So I hope you all got this, and we just put it the values in the Nernst equation. It was a very simple question. Now we'll be seeing what are the applications of Nernst equation. There are many applications of the Nernst equation. That is, we can calculate the EMF of the cell, we can calculate the equilibrium constant for the cell, and we can calculate the Gibbs energy also. So one by one we will be seeing how do we calculate the EMF, how do we calculate the equilibrium constant, and how do we calculate the Gibbs energy of a reaction, and what is the relation between these three. And let's start. So first of all, we'll be starting with the EMF of the cell. EMF of the cell. Actually, what is EMF? The electromotive force or the voltage. Actually, we are already solving that, and we have solved one question that was this the problem we solved, and I told you this EMF of the cell was calculated when we had E naught cathode minus E naught anode, right, and minus RT by NF ln the product's concentration or the anodes concentration here, anodes, and in the reactants, that is cathodes concentration here, right. This was the EMF of the cell. This I have told you already. So we will be moving on to equilibrium constant. So you will be asking how equilibrium is possible here, and we are not talking about equilibrium as we have a single equation. We have not put it the reversible equation sign here already. So actually what happens is, uh, if we take the example of a Daniell cell, if we take an example of the Daniell cell, what was the Daniell cell? It was equal to Zn solid plus Cu2 plus aqueous, which was going into Zn2 plus aqueous and Cu solid. There were two beakers, and we put it the zinc rod in the zinc solution and copper rod in the copper solution, and the bulb was glowing. And this, when till this reaction is happening, electricity is generated as electrons are continuously flowing, but and the cell potential is also developed in it. But after some sorted amount of time, you can see the voltage will be equal to 0. Why? As zinc is continuously getting converted into Zn2 plus, which is when zinc Zn2 plus concentration is continuously increases, and this Cu2 plus its concentration is continuously decreasing. So there comes a time when this reaction attains equilibrium and the potential becomes 0. So at equilibrium, E cell is equal to 0. So, and the equation for the Daniell cell, if we write, it becomes Zn plus Cu2 positive. There is a reversible sign here now. Why it is? Because the reaction attains equilibrium, no more electrons are getting no more electrons are flowing, no more electricity is generated, the potential has become equal to 0. It will be going into Zn2 positive plus Cu. The reversible sign comes here, and whenever the reversible sign is there and this reaction attains equilibrium, we talk about Kc. What is Kc? I have taught you in the chapter chemical equilibrium. It is equal to the equilibrium constant. Now we will be calculating the equilibrium constant using the Nernst equation. So we will be just writing the Nernst equation once again. E cell is equal to E naught cell minus RT by NF ln Zn2 positive plus Cu2 positive, right. So this is for the Daniell cell. We know at equilibrium this E cell, one second. We know at equilibrium this E cell is equal to 0. So 0 will be equal to an E naught cell minus 2.303. Again we converted ln to log. 2.303 RT by N, which is equal to 2 F log of Zn2 positive and Cu2 positive, which is also equal to Kc. As in the equation in the chemical equilibrium, we have seen that the product's concentration divided by the reactant's concentration of ions only is equal to Kc, that is the equilibrium constant. So we'll be equating it to Kc. 0 will be equal to E naught cell, and we know that 2.303 RT will be and divided by F will be equal to 0.059 minus 0.059 by 2 log Kc. This, and we calculate here E naught cell is equal to 0.059 by 2 log Kc, right? Or if we calculate for another cell, if we calculate this Kc and E naught cells equation with the use of another cell, so uh, in the case of 2 we'll be using N. So if we generalize this equation, which will be equal to E naught cell is equal to 0.059 by N log Kc. This is how we calculated the equilibrium constant using the Nernst equation, right? So now we'll be calculating with the Gibbs energy using this Nernst equation, right? Devyan Paul is saying hello. Hello. How is your preparation going on? You can just write down in the chat. Everything is well. Are you understanding the topic? Okay, we can just move on and we'll be seeing how we can calculate the Gibbs energy or the Gibbs free energy using the Nernst equation. Hi Pratik, how are you? One second, guys. Okay, so we'll be studying how we can calculate the Gibbs energy using the Nernst equation. Actually, where we studied Gibbs energy, we studied Gibbs energy in the chapter thermodynamics. Right. Here we studied what actually Gibbs energy is, and we calculated the equation for Gibbs energy, and we calculated the spontaneity, how spontaneous the reaction is, and we saw how Gibbs energy tells us the reaction is spontaneous or not. So if delta G is greater than 0, if delta G is less than 0 and delta G is equal to 0, what does it mean? If delta G is greater than 0, so we knew that the reaction is spontaneous. That the reaction is spontaneous. And if delta G is less than 0, the reaction is non-spontaneous. And if delta G is equal to 0, then the reaction is at equilibrium. We all saw that in the chapter thermodynamics. Now in this chapter, when we calculated and we saw how Gibbs energy is related to the E cell, then we saw delta R G, that is the Gibbs energy for the reaction of the cell is equal to minus NFE cell. This is the reaction we got, that how is Gibbs energy and the electrode potential or the cell potential is related. Then we saw how the standard Gibbs energy is related minus NF E naught cell. Right, and if we put this E cells equation for Nernst equation here, if we put the Nernst equation here, and we saw the if the reaction is at equilibrium, we know that delta G will be equal to 0, and we put the value of Kc in it, then we get a equation, that is delta G naught is equal to minus RT ln Ac. This is a very important equation. And we calculated how? We calculated it using the Nernst equation when we put it the values in this equation, in this first equation. Delta G is equal to minus NF E cell, delta G naught is equal to minus NF E naught cell, that is the standard electrode potential, and that is the standard Gibbs energy, and this delta G naught is equal to minus RT ln Kc. Now we got three positions here. When let me write this equation again. If delta G is equal to minus NFE cell, so we get to know if the E cell is less than 0, then always the delta G for the cell will be greater than 0, and it will be a, when delta G is greater than 0, then it is a non-spontaneous reaction, right? And if E cell is greater than 0, then delta G is less than 0. It will be a spontaneous reaction. Right. So we got the two conclusions here, that if E cell, that is the cell potential, is less than 0, then delta G is greater than 0. It will be a non-spontaneous reaction. And if E cell is greater than 0, then delta G will be less than 0. It will be a spontaneous reaction. Right, what is F? I have told you already. It is the Faraday's constant, it is the cell potential, and N is the number of electrons. So we'll be solving two questions after this. So let's solve the questions, and I'll be writing the question. So we have to write the Nernst equation and the EMF of the cell. We have to write the Nernst equation and EMF of the cell at 298 Kelvin, right? So first cell, I'll be writing the cell and you have to write the Nernst equation. You can just write down in the chat also. So Sn solid going into Sn2 positive, its concentration is 0.050 molar going into H plus 0.020 molar to H2 gas. It's 1 bar pressure. Right. So we have to write the Nernst equation and the EMF of this cell at 298 Kelvin. How do we do that? So we'll be writing the equation for the cell. What is the equation for the cell? Equation for the cell is, if we write Sn here, it will be solid plus 2 hydrogen gas, H plus. The H plus we'll be writing here. It is going into Sn2 positive plus H2 gas will be present. This is the reaction for this cell. So what is getting oxidized and what is getting reduced? Let me just, you can just write down in the chat what is getting oxidized. Tin is getting oxidized as it is losing 2 electrons, right? So, and what is getting reduced? Hydrogen is getting reduced as it is gaining 2 electrons given out of tin. So we have to write Nernst equation for this. What will be the Nernst equation? Nernst equation will be equal to E cell is equal to E naught cell minus 0.059 divided by n log Sn2 positive divided by H positive, and the stoichiometric coefficient is 2, so we'll be applying a square for this. The E naught cell is equal to E naught cathode minus E naught anode, right? What is E naught cathode? What is the cathode? The hydrogen part was the cathode. So E naught H positive going into H2 is the cathode minus E naught Sn2 positive going into Sn will be equal to, what is the standard electrode potential of the hydrogen? What is the standard electrode potential of SHE? You can just write down in the chat. What is the potential for SHE? It is equal to 0 minus, when we calculate or we see the tin's electrode potential from our NCERT book, every element's electrode potential is given there. So it is equal to 0.14. So the E naught cell for this cell is equal to 0.14 volt. Putting this value, E cell will be equal to 0.14 minus 0.059 by 2 log of 0.05 divided by 0.02's whole square, right? We'll be solving all these values and getting our answer to the problem. So I think that's it for today, guys. We have seen how Nernst equation works. We have seen the application of Nernst equation, and we have seen how Nernst equation is generalized for the cell, how we calculate and how we use the Nernst equation for a complete cell, how do we use Nernst equation for a half cell, for an electrode, how do we calculate the standard electrode potentials, how we calculate the cell potentials, and what are the applications, how do we calculate the EMF of the cell, how do we calculate the Kc, that is equilibrium constant for a cell, and how do we calculate the Gibbs energy for the cell, what are the uses, how do we know the reaction for the cell is spontaneous or not, and the reaction is at equilibrium or not. Everything we have already seen. We have solved 2-3 questions on Nernst equation. I hope all of you have got what is Nernst equation and how do we use it. what is the approach of solving the questions. uh, we'll be meeting soon in the next videos. I'll be explaining you more topics like these only. Till then, goodbye, have a nice day.